Howdy, y'all! I'm Rissy, molecular biologist and skincare-loving weirdo. Today, we're gonna talk about sunscreen, and specifically, mineral sunscreens. They're all over the news right now, and it's left a lot of people wondering whether or not they're an unparalleled destructive force of evil or the only good thing on this sinful earth. Well, what's the truth? Are they bad? Are they good? Are they better than so-called chemical filters? And how can you trust anything anybody says anymore? Well, we're gonna cover all that and more. We're gonna talk about the dangers of nano-sized zinc and titanium dioxide, and if there's anything really to that. Now, I highly recommend, if you haven't done it already, for you to go and watch my 3-part series on sunscreen, especially part 1. Just for general ease of understanding, I'm going to elaborate on that material with a focus on mineral sunscreen filters, how they work in contrast to organic or chemical filters, their advantages and disadvantages, what the science actually says, and the best way to use them. And make sure to watch through all the way to the end because I've got a big announcement. So to start with, ultraviolet radiation is really bad for you. It can cause sunburns and multiple types of skin cancer. The point of a sunscreen then is to take that dangerous energy and render it harmless. There's only 2 mineral sunscreen filters out there, and that's zinc oxide and titanium dioxide. The basic molecule of each of these is a metal ion, either zinc or titanium, bonded to oxygen. I should note that these minerals are also chemicals, so the perceived difference between scary chemical and innocent and holy mineral filters is fear-mongering idiocy, but we're gonna get into more of that later. We've got these 2 mineral filters. They're both crystalline solids, which is why when made into sunscreens, they can sometimes leave a white cast on your skin. Of course, who cares about that when they're the absolute best sunscreen filters ever? Because instead of absorbing all that nasty ultraviolet radiation from the angry sky gods, they block it from ever touching your skin, right? Right? No. This is the biggest lie in skincare. There's a lot of nonsense information out there about skincare, and I would put this lie at the absolute top in terms of most widely believed non-facts. I did a Google search, and like the top 10 pages about mineral sunscreens all reiterated this falsehood, this mendacity, that the way that mineral sunscreen filters work is by reflecting and scattering ultraviolet light. And this is absolutely untrue. This is the kind of programming that's really hard for people to shed themselves of simply because it is just so commonly repeated. That's absolutely not what the science shows, but we kind of knew that already, right? If these sunscreen filters literally reflected 100% of the light that comes in, your face would be a shiny silver robot mirror, right? We don't look like that when we put on sunscreen. You get a slight white cast. Brief side note, there's so many competing sources of information on skincare out there in the world, and if you're trying to filter out unnecessary info, then I highly recommend using this as a criteria to determine whether or not somebody knows what they're talking about. If they reiterate this idea that mineral filters work by blocking the sun and keeping it from actually touching your skin, they're an idiot who doesn't know shit about fuck. They didn't do any more research than the most basic Google search on Earth, and they cannot be relied on to give you good advice. But more importantly, here's a scientific paper that just straight out says it, that mineral sunscreen filters work the exact same way as organic chemical filters by absorbing the dangerous ultraviolet radiation that can cause damage to your skin and transforming it into something harmless. While this paper was published in 2016, it's building on information that's been known since the late 1980s. So it's not just that people are spreading a stupid piece of misinformation, it's a piece of misinformation that's 30 years old. And there's no reason why anybody who purports to know anything about skincare should repeat that. What titanium dioxide and zinc oxide to a lesser extent do is reflect and scatter visible light, not the ultraviolet radiation that we can't see, but the light that we can. And again, that's where the white cast comes from. But they only reflect and scatter like 5%. They don't do the whole spectrum, again, obviously, or our faces would look like mirrors. glimmers when we wear them. There's no such thing as something that you can wear on your face that literally would just bounce the light off of. Okay, lead. You could have a sunscreen made of lead. Do you want that? You don't, I guarantee. But what about the fact that mineral filters and chemical filters, they're so different? How can these things work the same way? Well, I'm glad you asked, because it is time to talk about solid snake physics. No, it's solid state physics. Fuck. After the cleanser video, I swore I was not doing anything with quantum electrodynamics again, but here we fucking are. I became a biologist to get away from this. If you boil it down to the simplest possible explanation, the way all sunscreen filters work is based on the fact that their molecules can take certain wavelengths of energy in the form of light, and the electrons in those molecules absorb that energy, get really excited about it, and then fart it out in a harmless form, usually as infrared radiation or just heat. That is true for all of them. Electrons are subatomic particles that carry a negative charge, and they're super important to how every atom in the universe is able to do what it does. The number of electrons that an atom has controls how many chemical bonds it can make, the nature of those bonds, and what the electrons can do within those bonds. The thing about electrons is they're a lot like toddlers. When that energy comes in and they absorb it, they need a lot of room so they can run and play and they can release that energy. And isn't that what you want with your toddlers? You've got to provide them the right environment. Well, how do you do that? In organic, aka chemical or small molecule filters, the electrons are given room to roam around the molecule because of the way the atoms are bonded to each other. These are primarily made out of carbon atoms, which is why they are called organic filters, because it's organic chemistry involving carbon. And the structure of the molecules is so you've got this alternating pattern of single bonds and double bonds. It's called a conjugated system, and it causes something called delocalization, which is exactly what it sounds like, that the electrons can just kind of delocalize. They don't necessarily have to hang out in just one spot. They've got a lot more freedom to run around, which again helps them expend that energy. If you look at the structure of the most modern chemical filters, it's literally nothing but a conjugated system. This is Tinosorb A2B, which has incredible broad spectrum protection, and look at its structure. Conjugation everywhere. But zinc oxide and titanium dioxide, it's just a metal ion and then oxygen. And they sit in a crystal lattice. Where's the electron play land? In order for the electrons to be able to romp and play, mineral sunscreen filters absorb and release energy like semiconductors. And what is a semiconductor? Well, oh boy, that is a really big question because that's a really big category. I guess what I would say is a semiconductor is a material that can regulate the flow of electrical current, meaning it can regulate the flow of electrons as they pass through it. There are some substances called conductors, and that's a lot of metals. Take the most basic example of copper. Copper wire is incredibly good at letting electrical current in the form of electrons move through it. When energy comes in, those electrons just zip right on down with pretty much no resistance. Then on the other hand, you have certain substances, and it's nearly impossible for electrons to move through those materials at all, and those are called insulators because they insulate from electrical current. So a semiconductor, therefore, is something that sits somewhere in the middle. I'm sure you can think of a lot of reasons why it is useful to have something between all or nothing, a setting between off and high. If you have used any electronic device ever in your life, which I assume you have since you're watching this video, you have used something that involves semiconductors. They are essential to pretty much everything in our modern world. Semiconductors are why we don't have to use vacuum tubes to build a computer that's the size of a house anymore. Now, the most common semiconductor that you've probably heard of is silicon, and silicon is used in making computer chips. Because again, it's very important to be able to regulate how electricity is moving through them. But we're not talking about silicon today, we're talking about zinc oxide and titanium dioxide, which are semiconductors. So they turn our skin into computer chips? They can electrocute us? No. Keep in mind that the energy that these semiconductors are taking in comes in the form of light. So unlike if your computer gets too hot because there's too much electricity moving through it and it bursts into flame, that's not gonna happen on your face. So zinc oxide and titanium dioxide are semiconductors. Okay, but how does that actually work? Well, it's all down to the electrons. Every solid has its own characteristic energy band structure. What's an energy band structure? Well, it refers to the levels of energy that the electrons in that substance can occupy. In every atom, you've got some electrons that stay close to the nucleus, close to the center of the atom, and then you've got what are called valence electrons that are occupying the outer portion of the atom that are free to make bonds with other atoms, free to participate in chemical reactions. And so we're going to be talking about specifically the valence electrons here. Part of this energy band structure is what's called the band gap. And bands, keep in mind, is just a level of energy from low to high. And the band gap is basically the difference in energy required for a valence electron to become one of those toddlers, a free electron that just wants to run and play. That band or level of energy is referred to as the conductor band. So taken together, the band gap is just the difference in energy between the conductor band and the valence band. And that tells you how much energy is required to get that electron super excited. And once it's promoted into that conduction band, it serves as what's called a charge carrier to conduct electrical current. In a conductor, the band gap is extremely small, almost non-existent. It takes very little energy to set those electrons free. In an insulator, the band gap is so big that there's almost no amount of energy that you could plug in to boost those electrons up to the conduction band. Well, without the thing getting so hot that it bursts into flames. But in a semiconductor, that band gap is just the right size so that it allows certain amounts of energy to properly excite its electrons. But it doesn't do it as easily as a conductor. Incoming energy disrupts the thermal equilibrium of the semiconductor. Those valence electrons absorb that energy, and then they are promoted to the conductor band. Now they can go play with their friends. This leaves behind an absence of an electron in the valence band, which is referred to as a hole. Promoted electrons can now move freely throughout the crystal lattice. But what goes up must come down, including energy levels. After they've had their fun, these drunk toddler electrons undergo relaxation. And the way they do that is to transfer that energy, which can be dissipated as heat. And in the case of zinc oxide and titanium dioxide, they can release it in the form of a photon in the infrared spectrum, which is not nearly as harmful to your skin as UVA or UVB, and in some instances can actually be beneficial to your skin. Once that energy is released, then the electron goes back to a state of lower energy, falling back into the valence band and filling that hole. And we end as we began, with all the valence electrons tucked neatly in their beds. They sure wore themselves out, huh? So zinc oxide and titanium dioxide work pretty much the exact same way that the chemical filters do. Doesn't that make them dangerous? No. There's this idea that got spread around the skincare community that the heat that's released from sunscreens is gonna damage your skin because heat can damage your skin, but no, the amount of heat is so very, very small. It's not changing the temperature of your skin. Keep in mind the packets of ultraviolet radiation that are getting to us are very, very, very small, and accordingly, so is the amount of energy released as heat. So that's not a problem either. Well, fine, but what about this new scientific study I've heard so much about that says that nano-zinc particles will make your sunscreen stop working after 2 hours and will fucking kill you? Okay, so it's kind of funny that this freaking thing happened right as I was preparing to release this video, because it was just going to be talking about semiconductor shit, but no, dumbasses had to go and ruin my weekend. This study is a crap study, not necessarily because it was done improperly, but because it's not actually telling us anything we didn't already know. What? So first off, this study didn't say jack or shit about the effectiveness of zinc oxide sunscreens. It used zinc to degrade other sunscreen filters. So there's no worries about your zinc oxide breaking down and not being effective. One of the main problems with mineral sunscreen filters is their white cast, which is of course the result of them reflecting and scattering light. Doesn't sound so good now, does it? Ha! You put them on your face and they can make you look ashy and gross. Part of that is the size of the particles. These are chunks of rock. This led to the creation of first micronized and then nano-sized zinc oxide and titanium dioxide particles. Nano-size is less than 100 nanometers, which is just so very itty bitty. As it turns out, this is a great solution to a lot of the problems that come with mineral filters. One thing mineral filters like to do is clump together, and that's bad because it leaves holes in your protection protection. If all the particles on this side of your face decide they wanted to concentrate into one gigantic zinc zit, then all of those areas that aren't the zit aren't getting the proper protection. So you want to be able to spread them out real good. Getting the particles really small allows them to spread out much more easily. It also really cuts down on that white cast. Well, that sounds great. That doesn't sound bad. But did you know nano-sized mineral filters create reactive oxygen species when they react with light? And yes, that is true. Nano-sized zinc oxide and titanium dioxide can, when hit with light energy, form what are called reactive oxygen species. Reactive oxygen species can be very bad. They can cause a very specific type of stress to your cells until they are quenched by an antioxidant. That's why everybody says antioxidants are great, because they can lower the burden of reactive oxygen species induced stress on your body. So yes, reactive oxygen species can be bad. They're also, though, one of the tools our bodies use to fight infections. There's a lot of scaremongering around reactive oxygen species, and that's a whole nother video, but they are not wholly bad. And in fact, the ability of zinc oxide and titanium dioxide to form reactive oxygen species that can cause cell death is currently being studied as a way of fighting cancer by killing tumor cells. So it's not all bad. But they degraded my sunscreen! Okay, so in this study, what they did was they showed that specifically avobenzone, an organic, i.e. chemical, sunscreen filter, loses its ability to absorb ultraviolet radiation, specifically in the UVA range. UVA rays are what's responsible for one of the nastiest forms of skin cancer, melanoma. Also, it causes most of the aging that we experience as a result of exposure to the sun. So that's really bad, right? Well, here's the thing. We've known that for like 20 freaking years. The FDA does not allow sunscreens in the United States to be formulated with zinc oxide and avobenzone in the same product for that reason. We knew. This is not new information. But they killed the fish embryos! Yes, that's exactly right. Reactive oxygen species formed by the degradation of mineral sunscreen filters is gonna strip away your mitochondrial membrane. It's gonna wreak havoc on your sperm and kill your precious fish embryos! Yes, this study showed the products formed by the degradation of avobenzone by zinc oxide are toxic to fish embryos. Here's the thing about fish embryos. They're a very popular model organism to study in biology because they're transparent. That's why you hear a lot about fish embryos, but we are not fish embryos. Our skin is not fish embryos, right? Things are very, very different. You can't just say, oh, the thing killed the fish embryos, that it's gonna be bad for us. Especially our skin, which is really good, as it turns out, at keeping harmful particles at bay. Also, avobenzone is like the high-strung thoroughbred of chemical filters. It's incredibly effective at absorbing UVA radiation, including the absolute tail end of it, which it's hard to find filters that protect from that. But like a thoroughbred horse, while its performance can be incredible, it's extremely fragile and it is forever breaking an ankle and having to be taken out behind the sheds and shot. It's really easy for avobenzone to break down and stop working. That's why it usually has to be stabilized through the use of antioxidants in the sunscreen or other chemical sunscreen filters that allow it to function more readily. So basically all of this study did is just confirm information we've had for 20 fucking years that you shouldn't mix zinc oxide and avobenzone, and specifically uncoated zinc oxide. Because that's the thing. Technology did not stop once it was discovered that formulation of zinc oxide could be used to protect you from the sun. Cosmetic formulators are constantly driving innovation to make better sunscreens. And one of the things that makes for a better sunscreen is coating the individual particles in a substance that lets them spread out more, reduces their white cast, keeps them from being able to form reactive oxygen species. This study is doubly garbage because the type of sunscreens that use uncoated zinc oxide is all like the clean beauty, natural beauty shit, and those sunscreens don't incorporate avobenzone, and even if they did, it would be illegal because of the FDA's rules. This study is completely and totally fucking useless, and the authors are obviously high on their own farts. They keep talking about, oh, no one has ever done this before. Lies, lies, lies. Just because something gets published doesn't necessarily make it good. But that's why you have people like me. Well, what about all the other stuff with the reactive oxygen species, like mitochondrial membrane destruction and sperm? Are you routinely hosing down your sperm with sunscreen? If you are, why are you doing that? Don't do that. That's a weird thing. Yeah, even like at a clinic, sperm samples don't need sunscreen. They're fine. They stay indoors. One of the problems with all of these studies that look at the toxicity of zinc oxide and titanium dioxide in the human body, it turns out it's pretty difficult for those particles to get through our skin barriers and to be just, running around fucking up your organs. If you see a study that has all this data on lung and liver toxicity, it was probably done with cultured cells and cultured tissue. So again, not representative of what's actually happening in your body. A lot of studies show that it's practically impossible for zinc oxide and titanium dioxide, if applied to the skin, to actually get all the way past the dermis and start entering the bloodstream from there. The real danger of these nanoparticles is inhalation from the people that are manufacturing them. Yeah, that is where the safety standards really need to come into play. If you're inhaling a bunch of this stuff, then that absolutely could cause a lot of damage to your inside. Which means that manufacturers of zinc oxide and titanium dioxide nanoparticles need to make sure that they have plenty of personal protective gear used during the manufacturing process. But for the rest of us, it comes down to just avoiding spray-on sunscreens, which I find suspect at the best of times because they have the unfortunate tendency of catching on fire. I guess if you have a powdered mineral sunscreen, don't, treat it like cocaine. But outside of that, you're gonna be fine, especially if the particles are coated. Zebrafish are not humans. Cultured cells in a dish are not humans. Why should I take that chance? Shouldn't I just go ahead and use the most natural form of zinc oxide sunscreen that I can find? Well, no. The problem with uncoated, non-nano particles of zinc oxide and titanium dioxide is they are awful to try and wear. They make for a really thick, chalky, nasty, white casty substance that can clump together, again, leaving holes in the amount of protection that you're getting, and just making it impossible for most people to be able to apply the right amount of sunscreen, which is crucial. If you can't apply 3 fingers worth of that sunscreen without hating it, it's not the right sunscreen. If you don't like the way something feels on your skin, it's probably going to be really hard to make yourself do it every day. So all these different technologies that allow for zinc oxide and titanium dioxide to get smaller and easier to wear are a good thing. The most important thing to keep in mind when you see these studies that are clearly written to scare people is that there's no evidence that sunscreen use has killed anyone. Not a single case on Earth, ever. But you know what does kill a lot of people? Fucking melanoma. So on one hand, we have absolutely no evidence that mineral sunscreen filters are bad for humans. And on the other hand, we have just a bunch of clown shoes nonsense. This also holds true for the coral reefs, by the way. There is not a single documented instance in the real world of sunscreen filters actually causing coral bleaching. None! Stuff to keep in mind when you're confronted with information that makes it seem like sunscreens are scary and bad. On the subject of coating, one cool thing about sunscreens is that there's always new technology coming down the pipeline. As we speak, there are labs working on not just coating the particles in a way that makes them less likely to cause any harm, but more able to protect you from ultraviolet radiation. It's really cool. Is there anything else I should be worried about? Generally exaggerated claims of what good sunscreens zinc oxide and titanium dioxide are. I'm not saying that they're bad, but the truth is that there are limits to what they can do because they're white rocks. There's only so small you can get the particles and have them still be effective. One of the few problems with nano-sized zinc is that it has problems absorbing those long-wave UVA rays that are so bad. What sunscreen formulators will do is have a mix of micro and nano particles so that you're still getting adequate protection while avoiding that white cast. If you're using a mineral sunscreen, make sure it's got zinc in it because titanium dioxide is great at absorbing in the UVB range and what's called shortwave UVA, but that long UVA where all the melanoma and aging comes from, titanium dioxide is actually piss poor at absorbing that. While you can get protection in the general UVA area with titanium dioxides, you are specifically lacking the protection that you can get from zinc oxide. That's the main issue with mineral sunscreens, is that there's only so much of the filters that you can add before where the sunscreen becomes unwearable. The limit is SPF 50 to 60 and a UVA protection factor of about 20. Now, this is an area of hotly contested debate in the scientific community, but all the evidence that I've seen seems to shore up that idea that, at least based on technological limitations now, you shouldn't expect a mineral sunscreen to have much higher numbers than that. However, those are perfectly fine. An SPF 60 with a PPD of 20 is great! That's a fantastic sunscreen, chemical or mineral. The main advantage of mineral sunscreen filters is that they're less likely to irritate sensitive skin in ways that some of the chemical filters, especially the older ones, can do. So in order to get proper UVA protection, you do need to use something with zinc oxide in it. You gotta use enough of it, the 3-finger or 1/4 teaspoon method at the very least for your face. And then when it comes to mineral sunscreens, you gotta use it like antibiotics, meaning that you get it and then you use it up right away. You don't want to let these just sit in your closet for a year and assume that they're gonna work fine. Why is that? Well, because the particles will start to come out of the liquid, they'll like float to the bottom. That's why so many sunscreens, like, you have to shake them up before you can use them. You need to redistribute the particles so that you're gonna get a nice even coat of protection on your face. If you take nothing else away from this video, remember the following things. Chemical sunscreens and mineral sunscreens work in exactly the same way. Sunscreen has never killed anybody, but skin cancer kills a lot of people. Some sunscreen is always better than no sunscreen, and the right sunscreen is the one that you'll wear every day. And speaking of that, in the next couple of weeks, I'm gonna be doing a mega review of all mineral sunscreens. That's right, I have scoured the earth for the absolute best in mineral protection for your face. It'll be coming at you very soon. So stay tuned, stay informed, and stay out of the sun, unless you've got a really nice sunscreen. Bye, y'all!